Hi everyone, this is Kilabash. Starting today, I'm launching a new video series to introduce my recently released Minecraft mod, Multiblocked2. Multiblocked originated in Minecraft 1.12 and later updated to versions 1.16 and 1.18. However, due to other project commitments and real-life responsibilities, the development of MBD paused, and it wasn't ported to higher versions. Last year, while developing the GregTech mod, I realized that the higher versions of Minecraft lacked an easy-to-use custom machine and multi-block mod. So, I decided to bring MBD to the modern versions. In the past, MBD 1 was known for its visualization and high level of customization, but it also had compatibility bugs and a steep learning curve. MBD 2 offers a fresh solution for custom machines. It completely reworked the MBD codebase, introduces a brand new and incredible modern visual editor, and provides more powerful customization options. This video is the prologue to the series, where I will demonstrate how to create a simple single-block machine using MBD2 and showcase some of its major new features. I won't dive into the detailed configurations of each module in this episode, but those will be covered in future videos. Unlike MBD1, MBD2 has removed the blueprint table. Now, you only need to enter the command /MBD2 editor to open the MBD2 editor. The visual editor in MBD2 is based on the code from MBD 1.18 and has been used in my other mods, so it may already feel familiar to you. If you find the visible area in the editor too small, as this video, you can adjust the window size in the View menu. I've chosen a size with 2 that ensures the actions are clear, even when viewed on a mobile screen. Let's create a new machine project. Starting with MBD2, single-block machines are separated into independent projects. For now, let's create a single-block machine project. I will cover how to create a multi-block project in the next video. First, let's familiarize ourselves with the new editor layout. At the top of the main view, we have the machine's configuration modules, which contain all the configurable aspects of the machine. A single-block machine has 4 modules: basic settings, machine traits, machine events, and machine UI. The panel at the bottom is the resource panel, which works like the asset manager in Unity or Unreal, where you can store reusable resources. On the right side is the configurator panel, where you can adjust the configurable parameters. The tabs in the top left of the configurator allow you to switch between the current configuration objects. In the Basic Settings module, we can configure the essential information for the machine. First, we need to assign a unique ID to the machine. Since we're creating a pedestal for fire, we'll set the ID to pedestal fire. The basic settings includes various configurations for the machine, such as block properties, block shape, sound, and the corresponding item properties. I won't go into too much detail here, but you can hover over the question mark icon on the right to view a description of each configuration. One important thing to note is that if your machine supports rotation to different orientations, you'll need to configure the rotation state to specify the supported directions. Since the pedestal doesn't have any orientation, I'm setting this to none here. In the main view, there are 4 connected nodes, similar to MBD1, representing the different states of the machine. By default, there are 4 states: base, idle state; working, active recipe state; waiting for a recipe; and suspend, machine suspended. The details of the waiting and suspend states will be covered in a later video when we explain recipe logic. The entire life cycle of the machine transitions between these states. If your machine doesn't need to process any recipes, you can delete all states except for base. Of course, you can also right-click to add custom states and trigger state transitions through the event system. This video won't cover advanced customization yet. When you select a state, the configurator on the right side switches to the settings for that state. Here, you can assign each state its own renderer, collision box, light intensity, and more. If a state doesn't have specific settings, it will inherit the settings from its parent state. Now let's try adding a new renderer for the working state. First, select the renderer in the resource panel, and right-click to add a new JSON model renderer. Double-click to open its configuration. We want to use the vanilla TNT model as the machine's model in the working state. Let's rename it to TNT, then point the model to the vanilla TNT model. And look, the TNT is here. Of course, you can also select your own JSON model file through the Select a Model option. Next, we can apply the new renderer to the working state. Similar to Unity, you can drag and drop the resources to apply them. Now, we have successfully set the renderer. You'll notice that both the working and waiting states share the same renderer, as the waiting state inherits the renderer from the working state. In this video, we are going to create a fire pedestal. I've already prepared a pedestal model with GeckoLib animations. The model was created by Mos, a very talented Minecraft artist. Big thanks to him for providing the model. Since MBD2 supports GeckoLib animations, this model comes with two animations, an idle animation and a working animation. Our goal is to have the machine play the working animation when it's handle recipes and the idle animation when it's not working. Let's set up our GeckoLib model as the renderer for the machine. First, we'll delete the unnecessary TNT model and remove the independent renderer for the working state. Then, right-click to create a new GeckoLib model and double-click to edit it. MBD2 has some built-in model configurations, but you can also select your own model file, texture file, and animation file through the buttons. After importing the model, drag and drop the renderer onto the base state. To have the animations play correctly, we'll also need to define the animation sequences and set the triggers for those sequences. I'll explain how to configure those settings shortly. Additionally, we want the fire pedestal to illuminate the surrounding area while it's working, but not emit light in other states. We can configure the light settings under the working state, setting the light level to 15, so the machine emits light when it's active. Similarly, we need to set the light level to 0 under the waiting state. Since the waiting state inherits from the working state, the machine should not emit light while waiting. We want the fire pedestal to generate flames by burning coal, so it needs an internal container to hold items. In the machine trait module, we can add various capabilities to the machine. For example, if the machine is a chest, it needs to store items and interact with pipes, so it should have item slots. Similarly, if it's a liquid tank or energy cube, it will need an internal container and the ability to interact with the outside world. In the machine trait configuration module, we can add these capabilities to the machine. On the left side of the list, you can right-click to add a new item slot. You can add multiple instances of the same capability, but each one must have a unique name in the configurator. The configurator on the right displays the configurable parameters for the item slot. For example, the number of slots. If you want to make a large chest, you can set it to a high number. Below that, the slot limit option allows you to set the stack size for items. Since our fire pedestal only burns coal, we can add a filter to the item slot to accept only items with a specific tag. Here, we set it to Minecraft coals. Additionally, MBD2 allows us to add advanced rendering features for the machine's capabilities. For example, in Thaumcraft, pedestals display the internal items in the world, or you might want to create a block like a liquid tank that visibly shows stored liquids. You can enable this by checking the Fancy Renderer option for world rendering. In this case, we adjust the render position to the top of the pedestal, resize it, and add some spin, resulting in a beautifully rendered pedestal with advanced visual effects. Next, let's save our project and restart the game to see how the fire pedestal looks. After restarting the game, you'll see that our fire pedestal has successfully appeared in the game. Let's place it and check it out. Remember the item slot we added? Let's try inputting items using a hopper. You'll notice that the hopper won't input anything because we set up a filter. Now, let's try inputting coal. The coal successfully gets transferred into the pedestal. Since we didn't configure the I/O capabilities, by default, the pedestal can both accept and output items. When we place a hopper underneath, it will pull the coal out of the pedestal. Attentive viewers might notice that when the pedestal's block is outside the player's view, the coal isn't rendered. This happens because Forge uses a technique called frustum culling to optimize rendering performance. If a block isn't in the player's view, its special rendering effects won't be processed. Additionally, we see that the pedestal's collision box doesn't quite fit the machine. Let's fix both of these issues. First, reopen the editor and the corresponding project. You'll see that the white box represents the collision box. You can hide this box by clicking the button in the top right. Another button controls the render culling range, which by default is set to the size of one block. Select the machine's base state and activate the render bounding box. By adjusting the parameters, we can ensure the rendered items are within the yellow culling range. Similarly, by adjusting the shape, we can modify the machine's collision shape and rendering frames. Now, both issues are fixed. Next, let's add a UI to the machine. After all, players wouldn't want to rely on hoppers to input fuel every time. First, select the Machine UI Configuration module. The MBD2 UI editor functions similarly to the 1.18 version. You can find tutorials for using the UI editor on LDUB's wiki. In future videos, I'll cover detailed UI customization, but for this video, we'll focus on some basic interactions that are often overlooked. You can hold Alt left-click to pan the UI widget, and hold Alt right-click to zoom the UI widgets. Holding Shift while dragging a widget allows you to move it under a group widget as a child widget. Additionally, after selecting multiple controls with Control, you can right-click to perform alignment operations. Unlike in MBD1, where users had to manually bind widget IDs, MBD2 automatically detects added traits and supports auto-adding widget with bound IDs. Here, the editor detected the item slot trait we added. By clicking the Add button, we can add the item slot, and the ID will be correctly bound to the trait name. Now let's do a simple UI layout setup. After setting up the UI, remember to save the project. Since we've already created the machine project, we don't need to restart the game. We can hot reload the configuration by entering a command. It's important to note that hot reloading cannot update most of the content in the basic settings module, as these need to be registered when the game starts. However, other modules' content can be updated dynamically, so the collision box fix we made earlier won't be reflected. Now that we have the machine's UI, let's add a recipe to it. First, we need to create a recipe type project. The first thing you should always do is set a unique ID for the project to prevent crashes caused by duplicate IDs. On the right side configurator, you can choose whether this recipe type will be displayed in JEI, REI, or similar mods, as well as select its icon, determine whether it requires fuel, and decide if it can proxy vanilla recipe types. If you check the Requires Fuel option, the recipe will consume fuel while it's running, similar to a vanilla furnace, and you'll need to add a corresponding fuel recipe. If you enable proxy recipe types, this recipe type will also support vanilla recipe behavior. For instance, if you want to create a machine that can handle all vanilla furnace recipes, you can proxy the vanilla furnace recipe type. The usage of these two options will be covered in a future video that explains custom recipe creation in detail. Right-click the recipe list on the left to add a new recipe. Note that recipe IDs must be unique, so we recommend using the Auto ID generator to create the recipe. Next, let's create a simple coal-burning recipe. Right-click the Import button at the top to add a new input ingredient. Select the ingredient and configure its details. In this case, we'll set it to the coal item tag. Similar to MBD1, MBD2 also supports probability-based inputs and other configuration parameters, but we won't go into those in this video. Next, let's add a condition to the recipe. The recipe will only run if all conditions are met. For our fire pedestal, we'll add a condition so that it only burns coal when it's raining. Finally, we need to design a UI for the recipe type that will display in JEI. Select the Recipe Viewer UI module, and the process is similar to setting up the machine UI. The editor will automatically detect the recipe we added and generate the UI controls with bound IDs. Go back to the Recipe Type module, select the recipe we just added, and open the preview window to see how the recipe looks in JEI. Now save the project and restart the game. After restarting the game, we can see the recipe type we created in JEI. Now, we need to set the machine to use that recipe type. Open the machine project, and at the bottom of the basic settings, select the recipe type we just created. After saving the project, use a command to update the settings. Then, place a new pedestal to test the recipe execution. Remember that we set a condition for it to work only when it's raining, so the recipe will only execute in the rain. You'll notice that the pedestal works perfectly, lighting up the surrounding area while the recipe is running. When there isn't enough coal, the pedestal will stop emitting light. Attentive viewers may notice that the machine isn't playing the GeckoLib animations while working. Now we'll explain how to set up GeckoLib animations and use a new feature in MBD2, the Custom Logic Node Graph. First, reopen the Machine Renderer configuration. At the bottom, you'll find the animation group settings. Although we have defined idle and working animations in the animation file, we haven't created the raw animation yet. A raw animation is a sequence which defines how internal animations are played. For example, playing animation A, then pausing for 5 seconds before playing animation B, and finally looping animation C. We can create a new raw animation, define the order in which animations are played, and tell the machine when to trigger a specific raw animation. Here, we'll create 2 simple raw animations, idle and working, both of which will loop their respective internal animations. Once the animations are set up, we need to tell the machine when to play them. In the Machine Events module, MBD2 provides a variety of event listeners. we want to play the working animation sequence before the recipe execution starts, and switch to the idle sequence after the recipe completes. So we'll edit the before recipe working and after recipe working events. The use of the node graph will be covered in detail in future videos. You can think of it as a control flow chart, similar to automation setups in Minecraft factories. Each event has a trigger start as the entry point, and it extends through yellow boxes to define the next action. First, find the GeckoLib animation trigger node in the left panel and drag it into the main view. Connect the triggered output of trigger start to the trigger input of the new node. This means that once the event is triggered, the next step will be to play the GeckoLib animation. You'll also need to input the machine and animation name for the node. The parameter panel at the top shows the event's input and output parameters, and you can drag the machine parameter into the node. Next, drag in a string node to input the name of the animation sequence, which in this case is working. Once the connections are made, the animation switch logic is set up. Additionally, you can use the debug panel in the bottom right to view the execution order of the nodes, which helps you understand how the logic is being processed. Let's set up a similar logic for the other event. After completing the logic setup, save the project and reload it to see the new changes. You'll notice that when the pedestal burns coal, the working animation plays, and after it finishes, it switches to the idle animation. A well-applied node graph can create many cool effects. For example, we want the fire pedestal to emit a fire effect made with Photon while it's working. Photon provides commands to generate effects, so we can set up the node graph to execute a command that triggers the fire effect during the machine's operation. As the prologue to this video series, we've demonstrated MBD2's modular design pipeline, briefly introducing the new visual editor and the node graph system. Using MBD2, we created a simple single-block machine, a fire pedestal that burns coal and lights up the environment. In the next video, we'll dive into how to create a basic multi-block machine. In the future, MBD2 will add support for more mods, and we look forward to seeing the creative machines you build using MBD2. MBD2 has already been released on Forge, though it's still in an unstable alpha stage. We welcome your bug reports and suggestions for improvement. MBD2 is an open source project, and we invite anyone interested to contribute to its development.